Good afternoon, everyone. Welcome to Forage Focus 2023. My name is Birgit Martin, and I'm the chair of the Ontario Forage Council. I'm pleased to see you all here today for our second of 3 noontime forage webinars. Before we get into today's topic, though, there are some housekeeping items to make you aware of. If you have any questions for our speaker, please put them in the chat at any time. OMAFRA's Forage and Grazing Specialist, Christine O'Reilly, will read them to the presenter at the end. And I'd also like to recognize the partners that are presenting this conference. They are the Ontario Forage Council and Dairy Farmers of Ontario. And now, today's 2023 Forage Focus webinar. Today's webinar is a recipe for better soil health, add forages. It's presented by Christine Brown. Christine Brown is the Sustainability Specialist for the Field Crops Unit of OMAFRA. Christine works with Ontario producers to address issues related to manure nutrient management, organic amendment use, and maintaining, improving soil organic matter with the use of cover crops and organic amendments. She is the editor of publication 811, the Agronomy Guide for Field Crops, and is a member of the OMAFRA soil team. Christine is a certified crop advisor with a 4R nutrient management specialty. She lives on a small farm near London, Ontario. Christine, welcome to Forage Focus. The floor is yours.
Thank you, Birgit. So today's presentation, recipe for better soils, add forages. So just to start off with a statement, the most resilient soils are often found on dairy and beef farms where perennial forages make up a significant proportion of the rotation. And I think we've all heard farmers talking about the benefit of the forages, benefit where they put manure on forages. And when I've often heard when people sell their farm or sell their quota in the cows, that it's about 8-10 years and they really start noticing the benefits that they were getting with their forages. So just an overview of what I'm going to present today. Just looking at the big picture first, how does forage growth improve soil health? Looking at a little bit of pasture versus mechanically harvested forages and how that pertains to soil health, and discussing some of the management for profitability and soil health. So yeah, we like to add forages for the soil health, but we have to remember that it's still all about profitability and livestock production. So how do we, I'm not going to talk a lot about the nitrogen credits of legumes, but legumes do provide a nitrogen credit that can help save commercial fertilizer dollars. Forages help prevent soil erosion, both wind and water erosion, and also helps to alleviate or prevent compaction, depending on forage selection. Forages in rotation increase biodiversity. Forages allow for the application of regular manure, and so forages and manure management have a lot of benefits for opportunities during the growing season that other crops don't have as much of, which helps with storage requirements and not requiring 365-day storage as opposed to somewhat less. Forages and regular application into forages can help with greenhouse gas emissions reduction and, of course, the improved soil carbon. And then a little bit of the fine-tuning, some of the things that there's research going on, but there's not a lot of research yet in Ontario on the different forage species and how those individual forage species impact soil health. So what is soil health? And so the definition that there's all kinds of definitions, but this is the one I like. Soil health is a suite of biological, chemical, and physical properties which enable soils to function as a vital living ecosystem that sustains all life. And this is the part I like, both above and beneath the soil surface. And how do forages specifically enhance soil health? Well, they capture more energy. They reinvest that energy or carbon into the ecosystem, and they allow for the recycling of nutrients. And so this is just a picture that puts that into words, but we've got solar energy, photosynthesis that comes from sunshine that produces soil carbon through the microbial activity and the interaction with microbial and roots and nutrients. Now that carbon will release some carbon dioxide, but we've also got the biodiversity that comes with adding forages with the soil carbon. We get food from meat production, milk production. We get manure production for recycling nutrients, and then we get fuel production. So it's a cycle, but healthy soils can capture, store, and release that energy. And when we've got forages, we have more opportunity for that. So in other words, carbon is the soil's capital. When I'm going to say soil economy is working well, then there's accumulated capital. And so carbon, what does carbon actually do? Well, carbon helps to maintain stability, soil stability. It allows expansion of the soil ecosystem. It can store and maintain productivity and add resilience to the soil. And really, organic matter can only be increased if there's excess carbon in the system. So rotations like forages or pasturing, cover crops, residue management, and added manure are all things that help to add carbon to the soil. And just to look at the impact that rotation has and the forages in rotation has, this is just some results, some early results from the Ontario Topsoil Survey. And that's a survey that was done across Ontario, at least below Sudbury. And it was looking at the upper slope, middle slope, lower slope, and looking at the topsoil characteristics with some management questions added for rotation, tillage, use of manure. But just the rotation part of it, this slide really shows how if you've got annual crops with forages, and I'm not sure if that includes cover crops or not, or if you've got perennial forages, so that would be like the pastures, it does make a significant difference in the organic matter level in the cropping. And this is over broad number of farms across the province, not a lot of details on exactly how long those rotations were in place, but where we had annuals with forages or perennial forages, there was an increase in soil organic matter. And then another way, or another study that showed some of the same kind of things. This is a study that was done, I'm calling it Bill Dean's research, but it was a bunch of researchers, and they were looking at comparing rotations for improving soil organic matter. And so they looked at a continuous corn rotation, corn, soybean, wheat, corn, soybean, wheat with red clover, corn and alfalfa, and just alfalfa. And I presented the numbers a little bit differently than they did, but looked at it at what is the estimated carbon capture in pounds per acre per year, and maybe more interesting, how does that reflect in time it would take to increase the soil organic matter by 1%. Now, 1% is huge. 1% isn't something that you're going to do in a few years, but it's an easy way to compare apples to apples in this context anyway. So with a corn, soybean rotation, you couldn't increase the organic matter by 1% with just rotation. But where you've got corn, soybeans, wheat, it would be about 81 using apples to apples comparison book values. Corn, soybean, wheat with red clover, instead of 81 years to get to 1% increase in organic matter, it would be about 62 years. Corn, alfalfa reduces it by almost half, 30, or not quite, 36 years. And if you've got alfalfa, continuous alfalfa rotation, 21 years. Now, it's still a lot, but it looks at that difference of that rotation effect in adding organic matter to the soil. So this is a bit of a busy slide. So because it's online, I decided I'd keep it and not make it into two. But maximizing soil health benefits with pastures. So if we look at pastures versus regularly cut hay fields, pastures are probably more beneficial to long-term soil health because the pastures are undisturbed for longer periods of time, in years. So sometimes instead of 4 year in rotation, it's quite a bit longer, sometimes 20 years plus. So you've got more time to establish the microbial populations, the root systems, and the soil structure without having it disturbed. Now, management does have some impact in that as well. You've got multiple plant species, And where there's multiple plant species, there's diversity in root systems, diversity in microbial populations, and even diversity in nutrient requirements. And so in the manure that gets deposited in the fields, what it will help to maintain more. There's very little nutrient removal. So where you've got grazing, especially where you've got rotational grazing, approximately 80% of the nutrients are added back to the field as manure. The rest is transported as meat or milk, meat or milk. You've got a long harvest period. So grazing often extends from April to October. So you've got maximum photosynthesis potential. And while you're grazing, that regrowth is maximizing that photosynthesis potential longer. Rotational grazing has potential for higher production. So anywhere from 40 to 100% more yield compared to full pasture. That's where you've got the livestock grazing the whole pasture all the time. Some of these comments, I listened to Mike Swiderski, who is a manager for Grey Dufferin Community Pastures. And so some of these comments it really hit home when he was talking about the impact of soil health that it was having on the pastures that he managed. But basically his management was to have a high livestock density in a relatively small area. Having water in every field would maximize that nutrient distribution in the pasture. So instead of the livestock going back and forth to the barn to get water, they're going to deposit a lot more manure around the watering system. Where that watering system is in the pasture, there's more nutrients distributed in that pasture. Managing for plant height and root stress. His comments were that root systems mirror the top growth. And we've seen that in cover crop studies. We've seen that in lots of times where we've dug up root systems and looked at biomass of the roots compared to biomass of the top growth. Fast grazing to avoid damage to the regrowth. So moving the cattle or sheep or goats or whatever to the next pasture before they start harvesting the new growth or damaging the new growth with tramping was going to help with yield and with soil health. Appropriate rest periods. So rest periods depending on how much water, what the growing conditions were. Uniform grazing to help with uniform manure distribution, and where there was nutrient requirements because of low fertility levels, adding compost for nutrients and for soil. Adding compost was the best for adding some nutrients and also encouraging the microbial populations and improving soil health. And so just a little bit on the benefits from amendments. And so when we add manure, when we add compost, when we add different types of amendments, we're adding a variety of food for a diverse microbial population. So for example, if I've got vegetative cover crops, I'm adding sugars, I'm adding cellulose, hemicellulose. If I have legumes, I'm also adding proteins. And if I have mature instead of vegetative growth, then I'm also adding some lignin, polyphenols to that mix. So I'm adding food for a variety of different food systems. If I've got manure or digestate or compost, again, I'm adding proteins, I'm adding lignins, I'm adding cellulose, I'm adding a whole bunch of different materials. And so then the microbial diversity in the pastures or in the forage crops, I've got bacteria that respond to the sugars, they respond to the proteins, they respond to the polyphenols. I've got some of the fungi that respond more to some of the lignins and the hemicellulose and the cellulose. Got mycorrhizal fungi that respond to the sugars and the proteins as well. Aminoacidomyces, which is a bacteria that likes the cellulose and the lignins. So I've got a whole bunch of different microbial populations that like different parts of the foods that are being provided by the forages or by the residue or by the different species that are in these forage fields. And the humus is humified by a combination of all of these microbiology. So fungi, bacteria, nematodes, protozoa, arthropods, and earthworms all combine to help make that humus component. And so this is a study that was done in the UK. And so I don't know what the comparison is in Ontario, but it was a really interesting comparison. And so I just thought I would share it because it really emphasizes the benefit of some of these microbial populations on the soil health, especially in forages and in pastures. So in this study, there was a stocking rate in the pasture of 16 sheep per hectare. And so then what they did is they looked at the different microbiological populations beneath the soil. And so they measured the springtails and the mites, which is one type of microbiology, and it equaled the equivalent of 1 sheep. Then they took the nematodes and they measured the nematodes, and it was the equivalent of 5 sheep per hectare of nematodes. And then they took the protozoa, which was equivalent to about 6 sheep. Then they took the fungi and bacteria, measured that, and it was the equivalent of about 17 sheep. Then they took the earthworms, which was equal to about 24 sheep. And so when you added all of that together, you had 16 sheep grazing above the surface, and you had the sheep equivalent of about 53 sheep per hectare in microbial populations. I thought this was absolutely fascinating because we know that there's diversity in microorganisms and we know that they're important, but we don't really think about that when we're adding manure, when we're adding forages, when we're adding organic amendments to feed some of those forage crops, or if we're adding fertilizer, which would change some of the microbial populations. And so the same study, and this is one where I was looking for some information from Ontario. There's some information from the southern states. There's some information from Western Canada. And again, this was put into a nice graphic form that I could explain a little bit more easily. But what is the impact of different forage species for microbial populations? And so in this graphic, they were looking at ryegrass. They looked at chicory. I'm not sure why they picked chicory, but anyway, chicory has a deeper root system than some of the others. They looked at red clover and they looked at white clover. And what they found was that the soil organism diversity was the highest in the white clover. You had more earthworms, you had more fungal feeding nematodes, more springtails, you had less, I can't even pronounce this word, herbivorous nematodes. And you had the lowest diversity where you had just the ryegrass, both in diversity, but also in soil organism numbers. And then the chicory was medium. The red clover was somewhere between the chicory and the white clover. And the red clover had the most predatory bites. The ryegrass had the highest plant-eating organism, or the highest herbivorous species. This study that was done in the States looking at different species showed that the tall fescues were the best, but tall fescues mixed with alfalfa was better than tall fescue by itself, both for microbial diversity, but also for soil organic carbon. So I think there's a lot to learn. I think that we get the best benefit where we've got combinations of grasses and legumes, and that's going to depend a little bit on what part of like your site characteristics, where you are for heat, for water, that kind of thing. And there's also some alternative forages, and these have a nice fit in soil health, especially in looking at cover crops or looking at emergency forages, or even alternatives to just, for example, if we've got corn silage that has some rootworm damage, or we've got high rootworm numbers and we want something different that can still give us a lot of feed value, we might be looking at alternative forages. So forages like winter cereals, cereal rye, triticale pea mixes, you've got lots of yield potential. But the nice thing about some of these is that it can take advantage of more growing degree days. So growing degree days of alfalfa is base 5, where growing degree days of some of these winter cereals would be base 0. So you've got longer period to benefit from the photosynthesis and build carbon. You've got winter cover potentially that protects the soil from erosion and also feeds the microorganisms during that colder season. Spring harvest for winter cereals with the potential to plant another crop. And again, so we're maximizing photosynthesis. Then we also have alternative forages like the warm season grasses, sorghum Sudan grass, which are basically somewhere between 45 to 60 days from planting to harvest. They have a massive root system. So you've got lots of, and remember, if the root system, the root system mirrors the top growth, well, if we've got that much root system, we've got a lot of potential for microbial interaction with those roots and a lot of carbon building potential. Water use efficiency, according to some comments that were made by Lawrence Levesque from Spear Seeds, water use efficiency for sorghum Sudan grass was 30 to 50% lower than corn silage, and it was also lower nitrogen requirements than for corn silage. There's high sugar content, 12 to 20%, consistent form of digestible fiber, but it requires proper harvest timing, and there's a reduced quality if it's harvested late. And of course, there's no frost tolerance with sorghum Sudan grass. But what I found interesting, and this was a comment also that Lawrence Levesque made, was that he made the comment of the mix that's available. But I was looking and thinking about it, and some of these forage mixes, cover crop mixes, forage mixes, are being marketed with a lot more soil health in mind. And I think this is a good thing. And so this is just one example of a mix that started off in northern New York, and it's been brought to Ontario and has been quite successful in providing good forage quality for sheep and goats. I don't know for dairy or for beef. I don't know the forage quality. So those are unknowns to me. They're not unknowns to Lawrence or to some of the people selling these mixes. But this example mix had 60% sorghum Sudan grass, 25% Italian ryegrass, a biennial version, 5% double cup red clover, 5% Basim clover, 5% hairy vetch. The hairy vetch, I guess that would depend a little bit on where you're located. It was seeded at 40 pounds per acre. It was seeded ideally after winter wheat harvest. So you've got some growing season left after winter wheat. This mixture grows well in the summer. The sorghum Sudan is going to be killed with the frost, but you still have the Italian ryegrass, which doesn't grow very well in hot weather or dry weather, but grows really well into the fall and spring. And then you've got your the clovers and the vetch. So the grasses with the legumes give you a diverse root system. The sorghum Sudan grass gives you a massive root system. You've got several opportunities for manure application in this mix. Potentially you could get 4 cuts. Now the questions I have is I'm not sure what the sugar or digestibility is of this mix. And I'm not 100% sure how you would manage, or I guess you would have to harvest the sorghum Sudan before you get the frost. But if you had an early frost, I'm not sure how that would affect the sorghum Sudan in the mix. But I think it's interesting that there are mixes, both cover crop with forage potentials, that are being marketed for soil health. And most of you have seen this slide before. It's one of my favorites, but it just looks at the synergy that you get with organic amendments and forages or cover crops. And so on the left-hand side, you've got cover crops without manure. On the right-hand side, you've got cover crops that had digestate added, and you can really see the increased biomass both in the top growth and in the root growth. And when we measured it, it was about a 40% increase in biomass, top growth biomass. The root biomass was a little bit too hard to measure. And so there were some studies that we've done. Again, some of you will have seen this before, but we did 2 years of growing after winter wheat harvest, growing cover crop oats that were harvested for feed, and that same cover crop oats with anaerobic digestate. 2 years in a row, similar yield difference, 1.9 tons per acre, 2.7 in the second year, 3.2 versus 4.4 for the cover crop oats with the digestate. And so I took that and looked at the milk program from Wisconsin to see, okay, how many pounds of milk per ton am I getting, to look at the quality aspects of it. And then looking at the yield plus the quality together, how many pounds of milk per acre am I getting per acre of forage? And so quite a bit difference. I'm getting 35 to 50% increase in milk produced with the cover crop where I've added the manure or the anaerobic digestate. And so what I wondered then was, what if we can get this much feed value in cover crops with organic amendments, then what happens if we add that back to, so basically plow it down or work it in instead of harvesting it? And what would that mean for feeding? Because if I've got 4.4 tons or 3.2 tons of material that I'm feeding cattle, what if I'm feeding the microorganisms below the soil with that? What kind of benefit does that have? And so we looked at, there's a lot of information here, but really just the blue section on the top is what I'm going to look at. So if I applied, again, looking at how long would it take to increase my soil organic matter by 1%. So just using book values with the information from this specific comparison for the 2 years. And so if I did just the anaerobic digestate by itself, it would take me 200 applications to get an increase of 1% organic matter. If I did just the cover crop oats without the organic amendment, it would take 26 crops, or I'd have to do that 26 times to increase the organic matter by about 1%. If I combine the cover crop oats with digestate, it would reduce it to about 15 times to increase the organic matter by 1%. So I'm feeding those microorganisms below the surface and getting a lot more carbon, increasing that organic matter a lot more quickly than with just cover crops by themselves, or with just digestate by itself in this case. And so this is going to take me to the manure section. We know with forages that there is a really nice opportunity for applying manure after cuts of hay. And so we asked the question, well, why would we apply manure to forages? Well, first of all, nutrients to growing crops prevents environmental losses, greenhouse gases specifically. And so, for example, if I'm emptying the storage in the spring or early summer onto forages, then I'm emptying that storage, reducing the amount of methane that's produced because the microorganisms in the manure storage need to reestablish themselves before methane losses occur. I'm also applying nutrients to growing crops, so the growing crop is using those nutrients quickly. I'm not losing them as nitrous oxide, compared to if I had a plume of nutrients sitting there in the spring that organisms weren't using right away. Another reason, supplementing the phosphorus and the potash that's removed with the harvest. I'm supplementing nitrogen for the grasses if I've got grass crops or grasses in the forage crops. I'm saving commercial fertilizer dollars, both from adding manure to the crops, but also in the nitrogen credits that I get the following year. I'm reducing the storage requirements, so I don't need a full year storage. I have opportunities in the summer to reduce the volumes in that storage. Spreads out the workload. Don't have to spread all that manure after corn harvest, which could be late, or before planting corn in the spring. And I reduce my spring compaction damage. And then the best part of all, I also, by adding manure, get about a 10 to 15% increase in yield or yield and quality. So there's a lot of good reasons. And just to go through, this is an example of some screenshots from our AgriSuite software. And I just wanted to show what the impact of adding manure and maybe some of the things that people don't realize with adding manure to a forage crop. So in this AgriSuite, it's the field management plan. And in this field management plan, I've got the seedling year of alfalfa where I'm establishing the alfalfa grass mix. I've got 2 full production years. And so it gives an idea of what is the nutrients that are being removed with a 5 ton per acre dry matter yield. So I'm basically, there's no nitrogen recommendation for alfalfa forages. So that one's, because I'm using hybrid. So this, I've got the option for agronomic crop removal or hybrid. Hybrid means I'm looking at nitrogen recommendations, but I'm looking at crop removal for phosphorus and potash. So you can see that over the full 3-year production, I'm losing about 100 or removing about 163 pounds of phosphorus, but I'm removing up to 750 pounds of potash. That's with not adding any manure, with not adding any fertilizer. That's just looking at what the crop removes. And so what I'm doing is basically reducing my soil phosphorus test by about 5 parts per million. I can reduce my potash soil test by as much as 35 to 40 parts per million, which if you've got, let's say, a 120 part per million soil test, I could be reducing that to under 100 very rapidly over a couple of rotations. I'm also removing about 40 to 50 pounds of elemental sulfur per year with this. So if I'm adding manure, also from the AgriSuite, the organic amendment calculator, if I've got liquid dairy, and I'm just going to use a database average of between 2 and 6% dry matter, I apply it after each cut, or at least plan to apply it after each cut. And it's applied to a standing crop, so I'm not incorporating it. I'm applying it at about 3,500 gallons per acre, ideally after every cut if the weather allows. So I'm getting about 30 pounds of nitrogen, 30 pounds of phosphorus, 70 pounds of potash with that application each time. And it gives me so the organic amendment calculator will tell me approximately what my nitrogen, how much of it's ammonia, how much of it's organic, how much is lost if it's applied in the fall especially. It will give me an idea of how much trace elements I'm applying if I've included trace elements in the analysis. It will also give me an economic value after the cost of application in available nitrogen, phosphorus, and potassium. And so this gives me an idea of what is my nitrogen, or sorry, what is my manure contributing? And it underlines the importance of having a manure analysis for the farm, because phosphorus and potash can vary from farm to farm, especially on dairy and beef farms or livestock farms that utilize forages. So back to my crop rotation. I've got my seedling year up here, my first full production year where I've added manure after first, second, and third cut because the weather was perfect. Then in my second production year, the same thing. So at the end of that, I've added about 217 pounds of nitrogen. I've added 11 pounds of phosphorus, about more than what the crop removed, but I'm still short on potash. So even though I've added manure, that manure cannot make up the potash that's from what's being removed in that forage crop. So I've pretty well balanced the phosphorus, but in this example, I'm still short about 16 parts per million in the soil test. And the sulfur basically balanced what was removed with the forage. So it's important to be aware that there is still some need for fertilizer potassium in high productive alfalfa grass forage mixes. And this is just one example, but it just gives an example of what can be removed and how to account for balances. So manure application to forages, just a couple of slides on it. The yield impact, we did quite a few years of studies, and the yield from surface applied manure from all the years that we did it ranged between 7 to 12%. in 1 year, sorry, in 2010, where we compared it to fertilizer, we had a 15% increase compared to the Czech, where we had a 6% with using a fertilizer equivalent. That was the only year that we did the fertilizer comparison. The quality differences, so that's looking at the Wisconsin milk program, milk per ton of forage, where we had the surface applied, we had a 5% increase. And then the yield plus quality milk per acre of forage, on average 12.5%, but both for manure and fertilizer there was an advantage, but more with the manure, and because it's got the trace elements, it's got the microbial benefits, the organic matter benefits. So I'm just going to see if this works. This is just an example of manure being applied using a dribble bar. And using this dribble bar, this is European technology that's coming to North America. But what it does is it applies that manure more uniformly in narrow bands, so there's less chance for loss, but there's also better distribution. You've got, in this case, it's a 50-foot boom, but you can have a boom that's as much as 120 feet wide. And so you're reducing the amount of compaction or wheel traffic. You're also covering more acres in a relatively short amount of time. So this is pretty nice technology where manure is being applied to forage fields on a regular basis, or to wheat, or to cover crops. So the 4 R's of applying manure to forages: your right source, obviously the manure that's produced on the farm, but is the better source liquid manure or solid manure? With solid manure, you need to be really careful how it's applied to forages. In the picture that we've got, this is an example of pretty bad distribution. There is no way that you're going to get away from smothering some of the crop. Nutrient distribution here is pretty terrible. The other source, sometimes if people are applying hog manure or anaerobic digestate, which has a different composition than dairy manure, then we need to be careful for what is the ammonia content. We adjust the rate so that the ammonia, the chance of burning crop is less. Nutrient composition is important, knowing what the nitrogen, what the phosphorus, what the potash content is, and then what is the forage type that the manure is being applied to. Is it mostly grasses? Is it mostly legumes? What is the stage of the crop? The right place is going to be the field that needs the fertility the most. So low fertility fields ideally are the best place to apply. Surface applied versus shallow injection. Surface applied gave us, depending on what the shallow injection was, if it was banded, that was great. If it was injected with something like an airway, we ended up with more crop damage, more root damage than with surface applied. Applying manure to ensiled haylage versus dry hay, the disease risk for yonis or something like that with wrapped bale silage is going to be higher than with ensiled haylage. Generally, the ideal is to put manure on fields that are going to be haylage or dry hay, not wrapped bales. So impact of wheel traffic, I'm going to talk a little bit about that, but basically, because of the impact of wheel traffic, we would not recommend applying manure to new seedings. We did have a farmer that was willing to try that for a year, and we basically did a lot of damage to the brand new crowns. And if you damage the crown when it's just being established, every plant is a crown basically waiting to develop into that crown. We ended up taking too many plants out and reducing the yield potential in those wheel traffic areas. So not recommended that you apply manure to a new seeding. So the right time for applying manure to forages during the growing season, when the crops can use the nutrients, because then you've got the lowest environmental risk for both phosphorus loss from runoff, or for greenhouse gas emissions. We've got lower risk of compaction, and we've got some options because we're especially in dairy farms that take off 3 or 4 cuts. I realize beef farms don't take as many cuts, so there's not as many options. But where you've got 3 or 4 cuts, you've got more options, so that if it rains after first cut and we've got wet soils and there's regrowth that's occurring too quickly, we've got second or third or fourth cut that we can apply. The most important time to have nutrients applied would be before the rest period, so late August, early September. It would be an ideal time to apply some of the nutrients. And then the right time is as soon as possible after harvest. Generally, that happens to fields that are harvested as haylage, because like you can see in the picture, they're harvesting the field and they're applying manure the same few hours after. So timing is critical. Apply as soon after harvest as possible. I told you that. In this picture, day 1 was the cut day, harvest was day 9 just because of weather conditions, and manure application happened at day 11 after cutting. And you can see that we did some wheel track damage. We had 32 and 49% yield reduction where we did this at 2 different sites, less yield, and there was lower maturity in the wheel track. So the lower maturity is not always bad, but the less yield just meant that we had just reduced yield compared to where we didn't have that wheel traffic. So when you think about the amount of wheel traffic and the impact it has on forage regrowth and yield, and so there's a lot of different pieces of equipment that travel over the field, and sometimes not all of those pieces are necessary. Well, I didn't add the truck that goes across the field, or anyway, mower and tractor, rake and tractor, harvester and tractor, forage wagons and tractor. If we're doing big bales or round bales, or then we have to pick up those bales, and sometimes that traffic goes all across the field. And then manure equipment plus the tractor. And the manure equipment, because and sometimes the forage wagons and picking up the bales is happening when there's already been some regrowth, and damage to that regrowth can be significant. And I'm just going to show you why. So one of the things to consider is the tire selection, PSI, inflation, deflation, and then the width of manure application specifically. How can I get the widest manure distribution so that I don't have to go wheel to wheel or as many trips across the field? So applying as soon after regrowth means that I'm not impacting the way that the regrowth occurs. And so the regrowth happens from both the apical buds on the stem and from the crown. I'm just going to go to the next slide and just show you. So this is a close-up of some of that regrowth. And you can see on the left-hand side, you can see that I've got some stems and I've got some regrowth that occurs from those stems, but I also have some regrowth that's occurring from the crown. And so this regrowth happens a couple of days after harvest or after cutting, depending when harvest is. But if I have wheel traffic from manure application, then I'm damaging some of this regrowth, and it basically all has to start over from the crown, and it's starting over a couple days later. So that's why I've got that delay in maturity, but I've also got the delay, the reduced yield, because I'm just not getting as much regrowth, and there's not going to be as much volume of regrowth. So this is normal regrowth. So this is a study we did in 2020. It was a very dry season. So this was on July the 10th, less than an inch of rain since the first cut. But this was the regrowth 1 week after application, both of the grasses and of the alfalfa. You can still see there was wheel tracks. This was the worst wheel track because they went over this part more than once, but you could still see some of the other wheel tracks in that field. This was the same day, same field, but it was the regrowth in the wheel tracks. And you can see that it's quite a bit lower. There's some grasses, but quite a bit lower for the alfalfa. This was 2 weeks after manure application where there was no wheel track damage. Again, still no rain, pretty good regrowth. The manure added some moisture, added a little bit of water content. And I don't know if I guess I didn't take it in the wheel tracks, but this was the after 2 weeks of after application. So there's other benefits, other soil health benefits from forages in rotation, and they are looking at that diversity in, again, in the microbial populations. But if we've got forages in rotation, it means we've got more crops in our rotation that help with pest management. So it helps provide unpredictable environments for pests. So for example, different planting and harvest dates compared to if we had continuous corn, for example, different row spacings, different seeding rates, different crop density, different dates for canopy closure. We've got timing and type and amount of tillage that varies by some of the different crops that we have in the rotation. And with the forage crop where there isn't any tillage in between because we've got it in place for more than a few years. And then the timing of products for fertility, for herbicides, and for pesticides. And so where we've got forages in that rotation, we have that variety, but also some years where we don't have to add herbicides or pesticides because we've got cutting rotations. So from a weed control perspective, where we've got herbicide resistance weeds, for example, Canada fleabane, which is a winter annual, or water hemp, which is a new weed that's an annual. Where we've got annuals in regularly cut forages, those weeds may germinate, but they won't establish because they're cut more regularly. So they won't have a chance to establish quite as easily. Now, having said that, you'll see in this picture, I've got two examples. This is a picture of a forage field with some fleabane in strips. And then in this picture of dandelions. And so one of the things that you do notice is the timing of cut versus when seed distribution is happening. And so with Canada fleabane, because it's flying, it can fly through with the wind quite a distance. There was some seed deposited in this field when the hay was cut and was waiting to be harvested. And so we've got some fleabane establishment. And so again, depends on regular amount of cuts, how that's going to be controlled and whether we get regrowth or not. You see that with dandelions as well sometimes, not that we can control dandelions because they're not annuals, but where we've got different cutting dates compared to when the dandelion seed is harvested or is being distributed, you can see sometimes different establishment of dandelions in fields where it was just cut versus where it was cut later. From a pest control perspective, forages in rotation can help defend against root damage from insects such as corn rootworm. So if we've got forages in rotation, whether they're annual forages like the sorghum Sudan grass, we're not going to get that same potential for rootworm damage and for lodging. And so it's an opportunity to help with pest control, especially where there's resistant pests. And then another one that I thought I would add, but forage production and harvesting earthworms. And I talked to quite a few farmers in the area that I'm in, which is the Oxford, Middlesex areas. And there's quite a few farms that take advantage of the potential income from harvesting earthworms. And earthworms, if you feed them, they will come. You can have quite a few earthworms where you've got regular manure application. Earthworm pickers, they prefer forage fields that have received regular manure application. They like picking conditions where the forage growth is short, so they can see the worms, but not crunchy. Because if the field crunches when they're walking across it, that would scare the earthworms. They can get earthworm populations as high as 200 worms per square meter, which is about the equivalent of 18.5 per square foot. Pickers are only going to pick adequately sized worms. These are worms that are for the fish bait market, and so they're only going to pick the big ones. They're not going to pick the tiny ones or the ones that are just in egg form. So the population will rebound back to the soil's capacity to feed them. And farmers get different amounts per acre depending on the frequency of picking and some of the parameters involved, like irrigating or manure application in between, that kind of thing. So in this picture, I've got a picture of what it looks like at the end of the, so close to dawn, early morning, when the pickers are finished in a field. Each of these boxes holds about 500 worms. They're sold as live fish bait. Worm pickers are expected to pick 800 to 1,000 worms per hour, and they can earn as much as $30 per 1,000 worms. So this is a lucrative business, and it's one where they like working with, especially dairy farms that have a lot of manure and are harvesting on a regular basis, or are willing to not harvest and just apply Roundup and keep it short for the season. So that's just another opportunity that exists for farms in some areas. So just to summarize, forages capture energy. They store energy as carbon in the soil. They recycle those nutrients. Rotational grazing and good pasture management can maximize soil health benefits. Management for profitability and soil health. If we remember that root systems will mirror the above ground growth. So if we've got good above ground growth and we're feeding that population, we know that that root system is also being maximized. Forages can help prevent soil erosion and compaction, so they can help with conservation measures. Forages in rotation increase that biodiversity, especially where we've got diversity in forage species, diversity in the nutrients and microbial components of the organic amendments that we're adding, the manure that we're adding. And then we can have synergies with manure and forages, so increased biomass and soil carbon production, greenhouse gas emissions reduction, especially for methane and nitrous oxide. And then we've got opportunity for crops with cropping some earthworms. And when it comes to species impact, there's still a lot more that we can learn from species combinations, which grasses give you, which root combinations of grasses and forages are going to give us the best forage production for milk and for meat, but also the best microbial populations. And so if there's any questions or any comments, I'd be happy to try and answer them.
Thank you, Christine. I will turn it over to Christine O'Reilly and present any of the questions that are in our chat.
All right. Thanks so much for your talk. We've got a few questions coming in, and I'd like to remind our audience that if you have something you want to ask Christine, stick it in the chat and I'll make sure that she hears about it. So the first question that I have for you is, if my main goal growing a forage is improving soil health. I know actually our main goal of growing a forage is to feed livestock, but for argument's sake, if my main goal is improving soil health, is it better to stick with my perennial hay crop, whether that's alfalfa grass mix or a grass clover mix, or should I switch to growing annual forage crops?
I think the right answer is probably a mixture of both. Because your opportunity with alfalfa grass mixes, you've got I'm going to say a schedule for cutting, a schedule for management. You know what you're getting with harvest. And I'm not a nutritionist, so I don't know the differences in, or I'm not as familiar with the differences in digestibility and sugars and all that kind of thing. But I think there's an opportunity for both. And that's why I really liked the mixture that Lawrence Levesque was talking about at one of the meetings I was at, where after wheat, you've got the opportunity to add to or combine some different types of forages without compromising your alfalfa grass mixes. And so you've got the opportunity of having that sorghum Sudan, having that winter cover, or planting cereals like cereal rye or triticale with peas or whatever, having that winter cover for protection and still being able to harvest a crop in the spring for, I'm going to say, a different composition of nutrients than you would get with the alfalfa grass mix. So I'm not sure if I answered that question from both profitability for yield production versus soil health, but I think it's a combination.
Okay, thanks. How does higher soil carbon with forages balance greenhouse gas emissions from ruminants? Or does it balance?
Well, I think it does. There's a lot going on with looking at carbon sequestration, and so carbon sequestration versus carbon storage. I guess I kind of use the terms intertwined, because with carbon storage, it means you're storing carbon, but I don't know if it's long-term, whether you can count it for carbon sequestration the same way that you would with, let's say, trees or forests. But just that we're adding that much more carbon means that we're storing it in the soil as organic matter, as soil carbon. So how does it balance with greenhouse gas emissions? So greenhouse gas emissions from ruminants is going to be mostly in methane from on pasture or from manure storages. And there's a lot of genetic manipulation going on to try and reduce the methane from different feedstocks or from animal genetic capacity. And I don't know enough to even, I just know enough to be dangerous. But I think the other part that we really need to think about is we're adding the nutrients, we're adding manure, we're adding nutrients to these forages during the growing season when the crops are growing. And if the crops are growing, they're maximizing the photosynthesis energy, storing the carbon. So you're not getting the losses from nitrous oxide emissions. So for example, if I put manure on after corn harvest this time of year, let's say I harvest my corn last week and I'm trying to get manure on anytime that there's frost in the ground, I've got a big plume of nitrogen, probably in either ammonia or nitrate form, sitting there in the spring. And if I've got cool, wet conditions in the spring where I don't have the microbial potential to convert that to the full nitrate, then it's going to potentially move off as nitrous oxide. That doesn't happen when you're applying manure to forage crops or in pastures on growing crops to the same extent. So yes, there's some methane, but nitrous oxide is worse than methane. So I think when you look at the carbon storage, and I don't have exact numbers, I'm just going by the principles that we talked about, but you're storing more carbon than you're losing in greenhouse gas emissions, but I don't know the exact numbers.
Okay.
And that's what the greenhouse gas calculator in AgriSuite can help with.
That was the next question, is there a calculator available for Ontario farmers to kind of figure out what their carbon footprint is or their greenhouse gas emissions might be?
Yeah, there's in AgriSuite, which has the organic amendment calculator and the field management calculator, and it has a whole bunch of different nutrient management tools that will help with all kinds of things. But it also has a greenhouse gas calculator that's meant as an educational tool. It's based on HOLOS, so it's based on what the experts in greenhouse gas emissions and the international community is looking at, and the algorithms are the same. But it puts it into a field-by-field perspective so you can get an idea of what are my losses. It gives a little bit of an idea of what is being sequestered, although that information is being fine-tuned as we get more information from the researchers. So there's a lot of research going on at Ag Canada, both out west and in Ottawa. But this calculator gives a really nice farm field comparison of, okay, this is if I wasn't doing all these best management practices, what would my greenhouse gas footprint be? And I'm doing these different practices, so here's the difference. And it's not total numbers, but it gives you an idea of what is the impact of best management practices.
Okay, thanks, Christine. And I'll stick the link to AgriSuite in the chat so that anyone who's interested in checking out that greenhouse gas calculator can do that. So another question is, you talked about how important it is to take a manure sample so that we actually know what nutrients we're applying to our hay fields when we're applying manure. So where could producers go to find information about how to take a manure sample and where to send it?
Okay, so taking a manure sample, there is there's some information on Field Crop News for sure. There's information in some of the best management practices guides, but basically taking that manure sample as you're emptying the storage, whether it's liquid or solid, taking sub-samples, putting them in a pail or in a bucket or on a sheet, and then mixing them and taking them to a lab. Any of the labs that do soil testing, that are accredited to do Ontario soil tests, will also do manure analysis. But when you're taking a manure sample, ideally from a nutrient perspective, especially livestock, where you're putting it on forages, it's good to get sulfur included. It's good to get micronutrients included. It's good to get pH and also carbon to nitrogen ratios, because that gives you a lot of information about nutrient utilization in that manure. But it will give you the phosphorus and potash as well, which is important from a how much commercial potash do I need to add to what my manure is providing.
Okay, thanks, Christine. I think with that, I'm going to turn things back over to Birgit.
Okay, thank you. And thank you again, Chris. Very, very informative. And soil health is extremely in everybody's minds at the moment. So this has been really, really good and fits well with what a lot of other organizations are working on too, OSCIA and others as well. So thank you again. And finally, I want to again thank DFO, Dairy Farmers of Ontario, for partnering with us at Forage Council in presenting Forage Focus to you. We have one final Forage Focus webinar tomorrow at noon again. So hope to see you all again tomorrow. Thank you again.